June 1283, Caernarfon, North Wales. Workers arrive at a construction site beside the Menai Strait. Quarrymen split stone. Carpenters prepare timber. Masons begin laying walls that will eventually rise above an entire fortified town. There are no engines, no concrete trucks, no electric cranes. And yet, what they are starting will still be standing more than 700 years later. This is how medieval castles were actually built. There was no single medieval castle design. Early castles could be built largely from earth and timber. They were fast to construct and useful when control of a territory mattered more than permanence. The timber had obvious problems. It could burn, it could rot, and as warfare changed, rulers increasingly rebuilt important fortifications in stone. Stone changed everything. A major castle was no longer simply a defensive structure. It became one of the largest engineering projects a medieval ruler could attempt. Before a tower could rise, someone had to solve a more basic problem. Where do you put it? A castle needed terrain that worked in its favor. A ridge could provide visibility. A cliff could remove an entire direction of attack. Rivers could protect walls while also moving supplies. Existing roads, ports, and crossings could make a fortress strategically valuable. But location created another problem. Stone is heavy. Transporting huge amounts of it over long distances without modern machinery was slow and expensive. Whenever possible, builders used material available near the site. At the modern experimental castle of Guédelon in France, researchers reconstruct 13th century methods using stone, timber, earth, and other materials found close to the building site. The experiment makes one thing obvious very quickly. A castle was not one building. It was an industrial system. Quarrymen extracted the stone. Stonemasons shaped it. Carpenters made scaffolding, floors, roofs, and lifting equipment. Blacksmiths produced tools and iron fittings. Lime had to be prepared for mortar. Timber had to be cut and moved. Ropes had to be made. Carts needed maintenance. And all of these jobs had to happen in the correct order. The first major task was the foundation. Builders removed loose soil until they reached ground capable of supporting the structure. Trenches were opened beneath the planned walls, then filled with masonry. Above them, the visible castle slowly began to rise. The walls were not normally made from thousands of perfectly carved blocks stacked like giant bricks. Carefully worked stone could form important faces, corners, arches, doors, and windows. Less regular stone and rubble could fill other parts of the masonry, bound together with lime-based mortar. This saved enormous amounts of labor. Because shaping stone was slow, a mason worked each block with hand tools. Simple pieces could be produced relatively quickly. Complex architectural stones around windows, doorways, and vaults required much more precision. Geometry mattered. A badly shaped decorative block looked wrong. A badly shaped structural block could affect everything above it. Once finished, the stone still had to leave the ground. That is where medieval lifting technology becomes surprisingly sophisticated. Builders used ropes, pulleys, wooden lifting machines, and cranes powered by human effort. Instead of an engine turning the drum, people supplied the energy. Loads of stone, timber, and mortar could then be raised to workers standing high above the ground. Around the walls, timber scaffolding created temporary working platforms. As construction moved upward, the working level moved with it. And the castle grew vertically. First a wall only slightly higher than a person, then another level, then another. Towers made the process harder. Doorways required arches. Chambers needed floors. Roof structures required large timber members. Spiral stairs had to fit inside walls and towers. Defensive openings had to be planned before the masonry closed around them. Changing one part could affect several others, which is why the most important person on a major site was not necessarily the strongest worker. It was the person coordinating the geometry.
The line is true.
Master masons could oversee the design and construction of enormous projects. At Conwy Castle, Edward I placed the work under James of St. George, an experienced master mason. The castle and its town walls were constructed in just over 4 years. That speed required organization on a remarkable scale. And Conwy was not unique. At Beaumaris, another Edwardian castle in Wales, records associated with the project show hundreds of masons and quarrymen working alongside a much larger labor force. A medieval fortress could temporarily pull people, money, food, timber, iron, and stone toward one location like a small industrial city. That also explains why castles could be extraordinarily expensive. Conwy is estimated to have cost around £15,000 at the time.
Keep pushing
the number
those stones
matters
up.
less than what it
Ready
represents.
the next layer.
A ruler was
Watch
not
your
paying
step
for a
on the
pile of
timber.
stones. He was funding years of skilled labor, transport, food, workshops, animals, tools, and logistics. And construction did not always proceed smoothly. Money could disappear, wars could interrupt work, political priorities changed, a ruler could die, labor could be redirected somewhere else. Some castles were expanded for generations. Others were never completed according to their original ambition. Beaumaris is one of the clearest examples. It was designed as an elaborate concentric fortress, with defensive layers arranged one inside another. But the enormous resources required for Edward I's campaigns were not unlimited. The castle remained unfinished. That may be the most important thing to understand about medieval castle construction. The impressive part was not that medieval builders possessed some forgotten technology. It was that they could coordinate ordinary technologies on an extraordinary scale. A quarry had to produce stone at the right speed. Carts had to move it. Masons had to shape it. Mortar had to be ready. Carpenters had to keep the platforms and lifting systems working.
The wagons are here. Provisions for the workers.
Good,
we're running low. Hand out the bread quickly. Work must not stop. Stone.
Break
Hoist
one
the stone.
link and construction slowed. Keep every link working and a wall rose. Today we can examine surviving castles, medieval records, and experimental sites like Guédelon to reconstruct much of this process. We can watch stone being quarried by hand. We can test lime mortar. We can operate wooden cranes and build walls using historical tools. But the experiment also exposes what was lost. Medieval builders did not leave us a complete instruction manual for every castle. Many practical decisions existed inside the experience of the craftsmen themselves. Their buildings survived longer than their working knowledge. 7 centuries later, the walls are still here. Some of the instructions are not.